Good afternoon, everyone. Welcome to the CGI stage for our Tech Talks. I'm Bernie Mongilio, Vice President for the Pittsburgh Metro for CGI. For those of you who don't know us, CGI is a large IT services and business solutions company. We do a lot of work in the big data space, which is part of the reason that we're here. I run our Pittsburgh operation, as I said. It's my pleasure to introduce each of our Tech Talk speakers. The first of which is Ben Schmidt, CTO of kWantera, and he'll be speaking to us about energizing your real-time big data. Come on, Ben.
Hello, everybody. So I've been told I have exactly 18 minutes. I think that I'm pretty sure something gets thrown at me if I go even a millisecond over, so I'm going to be very careful here. So today I'd like to talk a little bit about sort of where kWantera stands within the big data. It's called a revolution, although it started a long time ago, so I don't know if it's continuing to be a revolution or more just evolution. But the key aspect here, kWantera, at kWantera, big data is really our lifeblood, right? It's a calling for everybody that works for us. It's really the entire orientation from the time that we were conceived as a company until this day. kWantera has been entirely focused about how to do things at scale, right? So every single discussion we've ever had is around scale. And there's really only one parallel within the world, and that's really the big data revolution, is about how to do things at scale. Because big data has been around for a long time, right? It's really with this advent of big data that we're starting to get into the realm of, how do we do this we can't use a single computer anymore. We can't sort of look at the data ourselves anymore. You can't open up an Excel spreadsheet and just sort of like do a few little charts, right? You're starting to get into these new realms. And so that has a lot of interesting consequences, and the sort of specific niche that kWantera plays in really has some interesting complexities that start to come into play that really only big data and big data technologies can start to actually leverage. And the biggest one, and I think this is what I'd like to sort of center this talk around, is around, big data was sort of the original idea, right? So we have terabytes of data, or we have petabytes of data if you're big enough, and you want some way to do an analysis of it, right? So it's really translating data into information. And then you hope that with enough information or the right types of information, you can sort of make a decision. But now you start to get into the realm that this is not something that is oriented within kWantera, right? We're not trying to take lots of data and create information for kWantera. We're creating that information for our customers. And really, the customer doesn't really want just big information. I mean, broadly speaking, most people don't want more information. They just want better information, right? They want the right information to make a decision. And so now you're starting to get, okay, like you started with big data, you have sort of this big information pseudo word in the middle, but now you want to be big decisions. You want to be able to take and ingest lots and lots of data. You want to be able to translate that, do your analytics at scale on that data, and then you want to bake in individual customer recommendations, each individual preference to that data, and deliver it back to the customer in a way that makes sense to them, right? That helps them to make a decision, not just overloads them with more information, in which case you sort of get away from it being information and back into the data realm where it's like, this is really great, but I can't do anything with it, and it gets ignored, right? So how do you tailor those decisions at scale? So I've talked a little bit, so I mean, this is kind of the overarching theme of where kWantera sits, but what do we do? So kWantera is an energy firm. We trade and we help people buy and sell electricity. So wholesale power markets, the electricity you see in the building. Most of us in our houses are sort of largely absent of this market, but they actually look very close to like the NASDAQ or the New York Stock Exchange, where generators are selling power, large retail customers and like the utilities are buying power off that same grid. The power prices are going back and forth, and they're being cleared every 5 minutes, every hour at thousands and thousands of pricing locations. And those prices are dictated by the supply and demand, weather factors, predictions of load, all these different complexities. And in the end, you end up with this real-time ingestion of data, real-time clearing of prices, and then a few different financial ways that you can go about it, whether you buy it the next day or in real time. But the key is there's 7 of these ISOs within the United States. They cover the vast majority of the U.S.'s population. With the largest one, the one that we're in, PJM, they have like 90,000 megawatts on average that are put through the system at any given moment. So they're very, very big, complex systems, and the idea is that there are many, many players, and they all exist at a specific location, and that specific location dictates its own properties. Maybe you have a transmission constraint, or maybe you have a big generator down the street, or maybe you have a big wind generator or a coal generator down the street, and those prices will dictate, or those types of generation will dictate the prices that you see at your location. And so kWantera started with sort of just predicting those prices. So what we started with was if you have price forecasts of markets, so there are generally two, the real-time price right now for electricity, there's a price clearing this hour for electricity, and then there's a price that cleared for this hour yesterday. That's the day ahead price. And so those two prices can be different, but every single participant in this market needs to choose which of those markets they're going to play in. Do you sell in the day ahead, or do you sell in the real time? Do you buy in the day ahead or buy in the real time? And depending on who you are, you have different preferences for that. And this is sort of the sweeping generalization of what people are looking for. But if you're a buyer, you want the cheapest curve, right? So just purchase at all the times that one curve is below the other. It seems relatively simple, but the problem is that you have no idea what either one of those prices are going to be the next hour, the next day, the next week. And you're going to have to make big decisions about what exactly you want to do with your facility. Do you want to take all of your employees and tell them you have the day off because power prices are going to be entirely too high and it's just not economical for us to actually manufacture whatever we do? Well, that's a big call if you're trying to make it for next Monday, right? Because you don't know that those prices are going to come out and there's no way to guarantee it. So you're making a forecast off of that. And that's really where kWantera comes in, is that if you can figure that out and you can do it intelligently, you can mitigate those risks, well, now you can start to decrease your overall prices. But again, I come back to this idea that, right, this is for an individual customer to make a single decision at a single location within the market. But in reality, these markets are complex networks. They have interrelations. What happens in, we found crazy patterns, like if it's cloudy in Baltimore, you're going to have high power prices in Chicago. How exactly are you going to start to find those details, right? If you have transmission lines that run between certain areas, but it happens to be icing in the middle of Pennsylvania, but meanwhile in Virginia, it's relatively warm, you're going to have a different set of scenarios that are coming out. But if your particular facility is located in Ohio, you may or may not be exposed to those prices, and you're trying to make these decisions. Should I send people home? Should I double the workforce? Should we move our maintenance schedule from being noon till 4, which is the peak hour of pricing electricity? Or should I try to shift it to maybe 8 a.m. where power prices will be half of what they are at noon? So you're starting to try to bake in these pieces, but the idea, and they're just going to keep coming back to it, is that you have a lot of data. All of this data is just floating out there. You can go find the market prices. You can go find the ISO forecasts. But if you're an average facility and you've got maybe a few megawatts of load and you're trying to make these decisions, there's just no way that you could even consume that amount of information without building a big fancy system for yourself that can ingest it. That's problem number one. Problem number two, you then need to do some analysis on it. You need a forecast, right? You need some sort of machine learning, predictive analytics to get you into the next few hours. Now, if you're a single facility, you only have to do it at one place, but what if you're a conglomerate? What if you're a grocery store chain and you have thousands of stores across the United States? Well, now you're trying to do it at many, many locations simultaneously. Problems gets much, much more difficult. And then lastly, maybe one facility has this type of union contract, but this facility has sort of no union contract and can do this kind of thing. Now you're starting to bake in constraints for every single facility that are being updated in real time. And it starts to become this really complex, optimized decision, and ultimately getting you into the big decision realm. And this just kind of really compounds that same scenario where you're talking about individual customers, but each customer has their own orientation. So it's a market, right? Think of like the stock exchange. People are buying and people are selling. Well, here we have commercial and industrial that are trying to buy electricity. We have generators that are creating and sending the electricity out. And then we have the power marketers that are sort of the intermediaries buying and selling to the different parties and then trying to fix in their their margins. But the exciting part, or the really complex part, is that each one of those have slightly different perspectives, slightly different constraints, different ways that they can interact, different types of information that inform their final decision. And so you're trying to understand how all of these different players can really translate from information into decisions. And they each, just along the bottom there, I mean, lower costs for the buyer, higher revenues for the seller, and really minimizing volatility for all the intermediaries. But, I mean, those are just the basic financial components of what it is that they're trying to accomplish. So the really difficult part then becomes, I've talked a little bit about having forecasts a few days out, but you also have things that can react really quickly, right? So if right now, imagine we were sitting in the middle of July and there could be a peak load event, in which case in many of the markets, you pay based on the worst load that you've ever accumulated within the market. So if you saw that event coming, right, this hotel should go around and shut off all their lights because they could save themselves hundreds of thousands of dollars on their electricity bill in the next year's cycle. But how do you make that sort of decision, right? That becomes the fast component. You need to be able to do that in real time. That's one aspect. Then you have sort of the slower component, which is, you're trying to make a decision about next Monday. What should I do with my workforce? Should I bring them in, keep them home, double it up on next Monday? So you're starting to have systems that can have the leeway to actually make a forecast or to do the number crunching to get at a longer term forecast. They can afford the performance hit of that versus the system that are operating closer to real time, right? If you're trying to control your HVAC or your Nest thermostat at home based on power price predictions, well, those need to be fast, right? Our running joke is always, if you can create a model that predicts the next hour, but it takes you 3 hours to compute it, then that will not help anyone. It might be a nice academic exercise, but it's not going to get us an answer. And so that really starts to get into where the technology dovetails. And it's all about sort of building systems that are capable of being simultaneously fast execution and slow execution. And so how do you kind of go about that? This is where we layer in our own infrastructure. As with most people, we have sort of a database layer that sits in the bottom, but the idea around our database is that we have certain systems, certain components of that database. It's a DataStax Cassandra system. We have certain components of that can really quickly get the data and bring it back, and then we have other components that are a little bit more free to have less consistency, but that's allowable when you have much longer term forecasts. Then you've got your grid computing systems, and those are really where you're starting to mix in between, batch computing jobs and your traditional like ETLs versus like online computation, right? Messaging systems that can fire off that we're seeing power price spikes. That means we should go tell the lights or the HVAC at the Marriott hotel to start turning down because we're seeing that sort of event emerging. But that's the base infrastructure. From there, you get into the world in which you have kind of that middleware, right? This is where traditional analytics would come in, right? You have all of your data, and now you've got some framework in order to do the prediction, the analytics, right? So you take power price information historically, and you're starting to say where the next few hours are going to go. That's your big information, right? I now have an idea of where the forecast is going to be. You get one more layer higher than that, right? And you're starting to look at, okay, well now I have this information. I have this information at scale. So I have it at, I think there are like 60 or 70,000 pricing locations in the United States. You have each one of those. You have one of those for every single hour, and you have that going out a few days. Now you're going to try to bake in an optimization, that decision problem. You're going to try to sort of take every single customer's constraints, preferences, their orientation in the market, their risk tolerance, take that, combine it with the other pieces, and then try to deliver that as fast as you can, or in whatever time frame it is that they're interested in. And that becomes the really interesting piece. I think it's the part that has slowly emerged over time, where it's not just analytics on a large scale. It's now analytics on a large scale, sometimes quickly and sometimes slowly, but ultimately getting to that final decision, the thing that makes it so that you can actually push the button or not push the button, or go left or go right. And that's really the key for us at Quantera, and I think for a lot of you out there, that that's what we want. And And really, at the end of the day, that's always the customer's orientation, right? They want to have they want a technology, a solution that delivers them something that they can do something with it, right? They don't want to pay kWantera just to have another, little squiggly line on their monitor and then go, that's another great thing I'm going to ignore now. They'd like it to actually be useful. And so when you start to get into that it must be useful, you start to get into the realm of the big decisions. You want it to actually inform that decision. So I think that's probably my last slide. I think I have a few minutes. 3 minutes. So, well, thank you very much for all of your time. I don't know if we what did you say, questions, or we can do questions if anybody has a question. If not.
I do have one.
Sure.
I don't know if you, how do you capture this data? What is the technology stack that you use to receive all this information and process?
So we built most of our own internally. So we have grid systems that run in crons. We tried like a combination of like Mesos and Kubernetes. We ended up going with sort of a strange mixture of the two of them. But basically they're just, most of the ISOs publish publicly, so they're web scrapers. And then the other half of them use proprietary APIs of whoever we ingest the data from.
Okay, no, I've seen like data stacks. I don't know if that's, you guys using any of their products or not?
Yeah, we use the database is what underlies our system. Yeah, so I mean, the system that grabs the data is what I just spoke about, but it's the write in that's the much faster. That's the Cassandra component. We have a bunch of nodes that are just waiting to receive writes, and so they're just dumping data into the database all the time. Yeah. It's a great question. It's probably one of the most difficult questions. We'd prefer to just sort of crunch the numbers and be done with it. Unfortunately, nobody really likes that. So we have a web interface. We call it our Quant Hub. Everything's named Quant something. It's really clever. So it's the Quant Hub that you can go in, and from there the customer can look at either the raw information, so the actual underlying positions, or they can look at sort of our finalized, we think you should do this. We're trying to move into the realm where they can do the data science themselves in a way, in which they can take our raw positions, we can give them the optimized answer, but then they can start to take apart the probability distribution functions or whatever other sort of raw data we want. Since some people are wanting, they don't always want to just have the decision. They'd like all the information that's behind it. We've found time and again that when we give people both of those, they read the details for like the first few weeks, and then as we continue to do well, they stop reading the details. But that's just the way the cookie crumbles, I guess. Any others? Yeah.
Do you see the ROI for using this technology?
Yeah, that's an interesting question. Since we are a venture-backed startup, the ROI is basically the company. So it wasn't sort of a standalone investment. I think, I'm going to get thrown something at me. But yeah, it wasn't a standalone investment. It is the structure of the company. It's all about making decisions. Thanks.